All right, today's lesson involves word problems where we need to set up our own system of equations. Remember, a system of equations is two or more equations, which in Algebra 1 we are only dealing with two equations, and then solving. All right, so just to kind of go ahead and get started, let's look at number 1. Shown below are the graphs of x minus y equals negative 3 and x plus y equals 7. And by the way, they should have arrows on them, but it came off of a graphing calculator, so that's why it looks like that. But there you go. And that's the intentions. Name the coordinates of a point that satisfies x minus y equals negative 3, but not x plus y equals 7. Okay, well, first of all, we have to figure out which equation goes with which line. In order to do that, we're good at graphing equations if they're in slope-intercept form, right? If they say y equals something x plus something, right? We can figure that out. So what we're going to do is we're going to take each one of these equations and solve them for y. So x minus y equals negative 3. Come over here. Let's solve this for y, and then we'll be able to point to the line that it goes with. So in order to solve for y, we need to get rid of this x. Remember, that's a 1x, so we're going to subtract x, or subtract 1x, on each side. X minus x goes away. Now bring down that negative y equals, and remember we write the term that has the x first. So negative x and then minus 3. Now we don't want negative x, we want positive x. So we still need to divide by that negative 1 all the way through. So we have y equals negative x divided by negative 1 should just be a positive x. Negative 3 divided by negative 1 should be a positive 3. Okay, so can you see which line that would be? Can you see which line would be y equals x plus 3? Someone want to run up there and point to it for us on the screen? All right, go for it, Bryson. Which one? Okay, Bryson is pointing to this one right here. Very good. It is that one, okay? Remember that this right here is the y-intercept. You can see it's starting at 3, and then your slope is positive 1 over 1. And it's going up 1, right 1, up 1, right 1, up 1, right 1, all the way through. Okay, so then that means that this other equation must be here. So we really don't have to solve it for y. We know which one it is. Okay, so part A said name the coordinates of a point that satisfies this one, this red line, but not the other. So basically a point that would only be on that line. Raise your hand if you could give me a point that is only on that line I just highlighted in red, because that's the one that is x minus y equals negative 3. Bryson?
0, comma 3.
Yeah, 0, 3. 0, comma 3. That point is only on that line. That point is not on the other line, the black line. Okay, we got a red line and a black line. The red line has 0, 3. The red line has, who can give me another one? There's tons of them. Kyle. Negative 3, 0. Give me another one. How about, okay, Abby?
Negative 2, 1.
Negative 2, positive 1. Very good. Okay, those are all of these points all the way to right here, but not that one, right? Because that one works for both lines, right? And then all the points over here would be points for that line only. Okay, now name a point that's only on the other line. Who can give me a point that's on the other line, the one that I have in black there? Andrew?
7, 0.
Very good. 7, 0. There's tons of them, okay? Any of them on there. Now name coordinates that satisfy both equations. How many options do we have here? 1. There is only one coordinate that satisfies both equations. There's one solution that will work for both of those, and that is where the two lines, what? Intersect. So, Bryson, that would be at?
2, 5.
2, 3, 4, 5. Yes, good. All right. Hey, something that's really important that we haven't talked about that I need to make sure you understand. There are intercepts that are called the x-intercept and the y-intercept, okay? And maybe you would just be able to kind of figure this out. This would be the x-intercept for that line because that's where the line crosses the x-axis at that point. and this would be the y-intercept for that line because that's where that line crosses the y-axis. This would be the x-intercept for this line, and this would be the y-intercept for that line because that's where the line crosses those two axes. Okay, very good. Let's go on to the next one. All right, number 2. Now we're actually going to set up our own equation. So I really want you to pay attention here. Okay, there's going to be 2 types of ways that we're going to focus on setting up equations today. So let's go ahead and just read through number 2. Number 2 says, Fast Pick offers to process a roll of film for 30 cents per print with free developing. A competitor, QualiPrint, will process a roll for 25 cents per print plus a $2 developing charge. For what number of prints will the cost be the same, that's important, you should circle that, at Fast Pick and QualiPrint? So we have two companies here. We have Fast Pick and we have QualiPrint, right? And we want to know when they're going to be the same. Or in math, when are they going to be equivalent. Very good. So what I want you to do is I want you to write F equals Q. When is Fast Pick going to be equivalent to QualiPrint? Well, we've got to set up an expression for each one of these. So what expression could we use for the cost for Fast Pick? An expression that we could use that represents the cost at Fast Pick. It's 30 cents per print. That's all we know. Bryson?
F equals.
No F equals. Just tell me the expression.
Like 3/10 x.
Okay, sure. Okay, so he said 3/10. We can keep it as 0.3. We're going to use 0.3. It wouldn't matter though if you use 3/10. That would be fine. And he said 3/10 x or 3/10 p. Your variable is up to you. Because we're talking about prints, let's go ahead and use the P that you suggested to stand for prints, the number of pictures, okay? So we're going to put 0.3P here. All right, and then QualiPrint. We need an expression for QualiPrint. Who can give me an expression for QualiPrint? We're going to need to use P since that's the variable we've already chosen for our prints. Abby? 0.25P, 25 cents a print, plus 2 holes. Very good, because it's a $2 developing charge. So it's a flat fee of $2, but then it's 25 cents per print. We want to know when are these going to be equal to each other, okay? So we're going to solve this. Well, we have variables on both sides. We need to get rid of either the 0.3P or the 0.25P. I would suggest the 0.25P. That way we still have something left on that side. How can we get rid of the 0.25P? Subtract. We want to get rid of the entire term, so we add or subtract. Okay, now be very careful here. We have 2 left on this side. Think of this in terms of money. That's 30 cents, take away 25 cents. 5 cents, but 5 cents is not 0.5.
It's 0.05.
0.05, and then you have your P. All right, now I'm going to move this over here because I'm running out of room. So we have 0.05P equal to 2. Now how do we solve for P? Divide by 0.05, right? All right, so basically you're trying to figure out how many nickels it takes to make $2, right? That's basically what you're doing. Clay?
40.
Very good, 40. So, what does that 40 mean? Raise your hand if you can tell us. We need to make sense of our word problems. You have to make sure you've answered the question. What does the 40 that we just figured out represent? Malin?
It's the number of prints that they can get the same.
It's the number of prints you would have to print at Fast Pick and at QualiPrint in order for the cost to be the same. If you're going to order less than 40, it might be cheaper to go with Fast Pick, right? Because you don't have that, even though it costs more per print, you don't have that developing charge. But once you get past the 40 prints, it's going to be cheaper to go to quality print because, yes, you have the $2 flat fee, but then it's cheaper per picture. So Part B says, what is the cost for this number of prints? So for 40 prints, they want to know how much that's actually going to cost. Does it matter if we use the 0.3p and plug in 40 for p there, or the 0.25p plus 2 and add in the 40, or put in the 40 there? Does it matter which side we use? No, because they're going to be equivalent, right? So I would probably use the 0.3. That just seems like less work, right? 0.3 times 40. What do you get? $12. Everybody agree? You got calculators. You're allowed to use your calculators. Okay? So that is one type of systems where you set the two equations to each other. Because what you could have done is you could have said the cost for fast pick is 0.3p and the cost for quality print is 0.25p plus 2, and we simply set each of those equations equal to each other, right? We took this, if cost is 0.3p, then we put the 0.3p over here into this equation is what we did. Do you see that? So we still set up two equations. We just set them equal to each other. Okay? That's one method. Okay? That's the method you would use for that particular problem because of the word same. When you see the word same, you're going to set them equal to each other. Okay. Blair needs to rent. Oh, we're having a number 2. Oh, we did. I'm sorry. That's right. The graph was number 1. Okay. Blair needs to rent a car. She can choose from Luckey Rent-a-Car or Wambles Rent-a-wreck. Although I'm thinking you probably don't want to go with the Rent-a-wreck. But whatever. Luckey charges $59.95 a day plus 49 cents per mile. Wambles charges $81 a day plus 38 cents a mile. Let's just stop for a minute, okay, and let's write two equations for the cost to rent at each of those locations. So we've got Luckey, I'm going to put an L for Luckey, and W for Wambles. Who can tell me how much it would cost? C equals for Luckey's rent-a-car place. I need some different hands. You should be able to look at that. Luckey is $59.95 a day plus 49 cents per mile, and you should be able to set up an equation there. Michael?
0.49 M plus 59.95.
Okay, perfect. That's how much it costs. That would be an equation we could use to determine the cost at Luckey Rent-a-Car. So if we went 1 mile, we'd plug in a 1 here and we'd figure that out. Question, Bryson?
Wouldn't you have to add plus the number of days because it's per day?
Well, you would if we were going to do multiple days, but let's say in this situation we're just going to do for 1 day. Okay? And then over here for Wambles, who could come up with an equation for this one? Abby?
0.38 M plus 81.
Good. All right, part C says determine the mileage for which the cost of Luckey and Wambles would be the same. So you should know what to do with those two equations. What are we going to do with them? What do we? If C is this, right? Then can we take this and put it in for C over here? If we're wanting to know when these are going to be the same, we're going to set them equal to each other.
Yes.
Okay, so 0.49 M plus 59.95 equal to 0.38 M plus 81. We're going to set those equal to each other and we're going to solve. Let's get rid of the variable that we have on each side. Which one do you want to get rid of?
38.
Okay, so let's subtract the 0.38 M on both sides. 0.49 minus 0.38 is 0.11 M plus, bring down your 59.95 equal to 81. What's next? Subtract your 59.95. Okay, you've got calculators. Go ahead and make use of those. So 0.11 M equals $21.05, 21.05. Last step, divide by 0.11. So what do you get?
No, because it ends at
191 point. Okay, it is this. It's 3-6 repeating. The only reason it's ending in a 4 is because your calculator has to stop at some point, so it's taking the 6 at the end and rounding the 3 up to a 4. So, but if we're talking about, approximate, and it doesn't say approximate, but in this case, and it doesn't say what to round to, I would have to be pretty flexible on answer. I would take 191. I'd take 191.4. I would expect you to round. If you had a repeating decimal like that, I would not expect you to write 191.3. If you're going to stop, you need to look next door and see if the number is supposed to remain the same or round up. So we can just leave it like that for right now. So find the cost. So the cost, we're going to take that and we're going to plug that in, right? So I'm going to take I like the 0.38 M plus 81 best. So I'm going to take the 0.38, I'm going to multiply it by 191 I'm going to put in 4. I'm going to hit enter, and then I'm going to add 81. And how much does it cost?
153.732.
Okay, money though, money should be $153.73 because the 2 isn't going to round the 3 up, correct? Do you see how to work that? All right, the only new part here was this part up here where we had to set up the equations equal to each other. You should know how to solve equations with variables on both sides. You should know how to take a value and substitute it in. It's a lot of work today, but the only new part is writing the equations. And you've actually done a little bit of that already before. Any questions so far? Okay, let's look at number 4. Now this one's going to be set up a little bit different, okay, because you're not going to have the word same in here. It says 2 pounds of stew meat and 6 pounds of ground pork cost $12.30. 3 pounds of stew meat and 2 pounds of ground pork cost $9.70. Find the cost per pound of each kind of meat. These are actually really easy to set up. Nowhere in this problem do you see the word same. Okay, so what we're going to do is we're going to write one equation using the first sentence and one equation using the second sentence. But before we do that, we have to decide what variable we're going to use. We're talking about stew meat and we're talking about pork, ground pork. So I'm going to use, because S looks kind of like a 5, I'm going to use M to represent, what should that represent?
Stew meat.
Okay, but what about the stew meat? What are we trying to figure out? The cost, right? Cost per pound of stew meat. You have to write all this out. This is called defining your variables, telling me what your M stands for. If all you put is stew meat, then does that mean you're trying to tell me how many pounds of stew meat, or are you trying to tell me the cost per pound of stew meat? It wouldn't be how many pounds because it's telling you 2 pounds of stew meat. Do you see that? So it's the cost. Okay, and then we're going to use P for the cost per pound of pork. All right, so the first sentence. 2 pounds of stew meat. So 2 M and plus 6 pounds of ground pork. 6 P costs $12.30 equals 12.30. Boom. Equation 1 is done. See how that goes? Okay, try the second one. Okay, second one. 3 pounds of stew meat. 3M plus what? 2P equals? Okay. So if we have to figure out the cost for each of those, that means we have to figure out what M is and we have to figure out what P is. We know how to do this. Look at those two equations. When you look at those two equations, do you look at those and say, oh, the easiest method would be to graph? No, because you'd have to solve both of those for either M or P, right? So that you had it slope-intercept form and then you graph. Do you look at those two equations and say, oh, the easiest method would be substitution? No, because I would only do that if it said M equals already, right? Or P equals, so I had something to plug into the other one. You should look at that and say the easiest option would be to solve these using elimination. Okay, so looking at that and knowing what you know, raise your hand if you can tell me which equation, because obviously nothing eliminates right away, we would multiply, and what would we multiply by? Abigail?
We'll multiply the second equation by 3, negative 3.
By negative 3, because by multiplying by negative 3, in here, that's going to give you a negative 6, which will cancel there. So that's what we're going to do. Very, very good. All right, so I'm going to go ahead and just copy this top one over here, because we're going to leave that alone. All right, now the bottom one, distribute. Negative 3 times 3M, negative 9M. Negative 3 times 2P, negative 3 times 9.7. You've got a calculator. Please use it.
29.10.
Should be negative. Negative what?
29.10.
Negative 29.1 or 0.10? Very good. We are talking about money, so you could do that. All right, so let's add these together. You know those are going to cancel. 2 plus a negative 9 is a negative 7M equals. Now 12.3 plus a negative 29.1. Be very careful. What is it?
Negative 16.8.
Okay. Last step. Divide by negative 7. So M equals 2 point what? Oh, 2.4. I thought you said 2.24. 2.4. Is everybody in agreement on that? So what does that mean?
That each pound of stew meat costs
$2.
$4.
Okay, good. So each pound of stew meat costs $2.40. You can put a 0 on the end there. Put it up there where your variables are. And you're going to want to box that in here in a minute. Now, we still need to figure out how much the pork is. So what do?
We just plug that in for
We just read
M.
it.
Very good. We plug that in for M. I'm going to take the first equation. This 2M plus 6P equals 12.3. And I'm going to plug it in for M right here. 2 times 2.4 plus 6P equals 12.3. 2 times 2.4 is 4.8 plus 6P equals 12.3. Subtract the 4.8. 6P equals, what is it? 7.5 or 7.50. Divide by 6. And P equals 1.25?
Yeah.
Okay, so what does that mean?
Each pound of pork is $1.25.
Each pound of pork is $1.25. That's very cheap. All right, so there you go. It's a lot of work. But other than writing the two equations, that's all work you've done before, right? You just had nice integers to work with. You didn't have money. You didn't have decimals, really, to work with. Correct? Okay, you can do this. And you're allowed to use a calculator, so take your time and do a good job. All right, number 5. In one day, a movie theater collected $4,275 from 675 people. The price of admission is $7 for an adult and $5 for a child. How many adults and how many children were admitted to the movie theater that day? Okay, does it say anything about same, when two things are going to be the same? No. So we're going to set this up like the last one where we had 2 equations, right?
Yes.
And we solved it using elimination. What 2 things are we talking about here? Adults and children. And we're supposed to figure out how many adults and how many children. So the A is going to stand for what? The number of adults. Don't just write adults. The number of adults. Because in this situation, is it the number of adults or is it the cost for an adult? Well, we already know how much an adult costs, right? So it's not going to be the cost per adult. It's how many adults. And C is going to stand for the number of children that went to the theater this day. Who can tell me one equation that we could set up here based on the information that we know? Now, it's not going to come straight from one sentence at a time like the other one. You're going to have to stop and think here for a minute. Okay, so let's do this. Let's talk about the number of people that went to the theater that day. We know adults and children went to the theater, right? And what do we know about that?
Each adult costs $7.
Not the money. Talk about the number of people that went.
675 people.
Right, 675 adults and children went to the theater that day. How could we write an equation just from that?
A plus C equals 675.
Is that what you're going to say, Abby? Okay, good job. Good job, guys. A plus C equals 675. The adults plus the children is equal to 675. That makes sense, right? Now let's talk money in the second equation. How much is each adult? $7. Okay, Michael, you want to give me this one?
7A plus 5C equals 4,275.
Yes, sir. Very good. Very good. Okay, you see how that works? The top equation deals with the number of people that went. The bottom equation deals with how much it costs for them to go. So let's solve. These have ones in front of them, right? So we need to solve using elimination. So we're going to have to multiply the top, and you can multiply by either -7 or -5. What do you want to do? -5. Okay. So let's distribute that through. So -5 times A is -5A. -5 times C is -5C. -5 times 675. You're going to have to figure that out. Okay, there we go. Now, this one is just going to come straight over. And we're going to add them together. The C's are going to cancel, right? Yeah. -5A plus 7A is going to be positive 2A equal to? What do you get?
-2A.
2A equals 900. Divide by 2, and A equals 450. So what's 450? 450 adults went to the movie theaters that day. How do we figure out how many children went? Clay?
you just subtract that from 675?
You can, because if you took the A plus C equals 675 and you substitute the 450 in for A right here, like this, isn't that all you're really doing is just subtracting 450, right, from 675? And what do you guys get?
225.
So come up here by your variables and put 225. Very good.
So it's twice.
Are you guys doing okay? Okay, you'll see though when you do more problems, you'll see the ones that are like the stew meat that go sentence by sentence, and then you'll see the ones like this where you have to do one equation deals with how many of something and the other one deals with the cost per. All right, number 6. Jarrell, do you have Jarrell or do you have a different name? Do you have Jarrell? Okay. Jarrell has 8 coins in his pocket. They are a combination of quarters and dimes. The value of the quarters and dimes is $1.55. Write a system of equations that represents the situation. Well, before we write a system, we need to talk about what variables we're going to use. What variables are we obviously going to use here?
Q and D.
Q and D. Q is going to represent
Number of quarters.
the number of quarters, right?
Yes.
And D is going to represent the number of dimes. So we need 2 equations. Can somebody give me one equation?
Q plus D equals 8.
Q plus D equals 8, right? Because it says there's 8. That one's tricky. The number is spelled out. It's not actually typed. Q plus D equals 8. Okay, second equation. Some people struggle with this one because they don't see any more numbers, but some of this is common sense.
Oh. 0.25.
Oh, 0.25Q. Well, how do you know that? We don't have a 0.25 in the problem.
Because it's quarters.
Oh, a quarter's 25 cents. Oh, okay, good. Plus what? Plus 0.1 D equals what?
8.
1.55. Okay? So find how many quarters and dimes he has in his pocket. Now, you could sit there and play around with the numbers. You could. Or we could just go ahead and use our elimination method that we know, right? So let's do that. So we have 1Q plus 1D equals 8. 0.25Q plus 0.1D equals 1.55. What do you want to multiply the top by? Negative 0.1? Okay. So we get negative 0.1Q minus 0.1D equals negative 0.8, right? Copy this other one over. And we can add these together. The D's are going to cancel. So we've got a negative 0.1, which is like a negative 10 cents, right? Plus 25 cents. You should be able to do that in your head. Point.
Wouldn't
Jay Riley?
on the first one where it just was Q plus D, how did you go from being just a 1D to a 1D?
Because we distributed this. When we decided to multiply by negative 0.1 so that our D's would eliminate.
I didn't see that the number we divided by multiplied by was 1.
Yeah, that's okay.
Or
So now we're trying to figure out negative 0.1 plus 0.25.
0.1
0.15 Q equals. Now that's like a negative 80 cents, right?
2.35.
Nope.
Equals 7.
It's 75 cents.
Oh,
Point,
75.
0.75. Divide by 0.15.
Equals 5.
Q equals 5, right? So there's 5 quarters. Well, that makes it easy. How many dimes are there? 3, because there's 8 coins in his pocket. So you're able to just put that in there, right there. Hi.
Miss Wilson,
Good morning.
what you doing?
We're recording a lesson.
Am I?
You're back on my YouTube video.
Well, yeah, I am so glad because I was just doing the juju on the beat over there on somebody else's video this morning. I'd much rather be on yours.
Oh, okay. Doesn't that look like fun?
Yes.
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 Good answer, Mr. Moses. Do you guys have any more questions about this particular problem? Okay, I want you to look at the next one.
So what
See if you can set up your own equations.
It's secondary.
Make sure the first thing you're doing is you're writing what 2 variables you want to use. Let's go ahead and discuss that. What 2 variables do you want to use on this one? P for what?
Peanuts.
Peanuts. What about the peanuts?
Number.
The number of pounds of peanuts. And C for what?
Number of pounds of cashews.
The number of pounds of cashews. This one is a little bit tricky, okay? Now, not the first equation. The first equation should be easy, right? Because you know how many pounds altogether you have. What's the first equation going to be? What do you have? P plus C equals 10. Oh, this isn't the tricky one. I think I took the other one out. Okay, so then the second equation, the peanuts are $3.60 a pound. So you're going to put 3.6 P plus what? 7.9 C equals. Oh yeah, this is the tricky one.
It's decimal, so
Okay, but hold on. What does the 5.32 represent?
Or
How
how much
pound
it
of
made?
the mixture.
1 pound.
Mixture of both.
1 pound of the mixture. Are we just trying to create 1 pound? We're trying to create 10 pounds.
So it's 53.2.
Yes. So 10 pounds at $5.32 a pound is $53.20. So this should be equals 53.2.
That makes it so much easier.
Okay? Now, I'm going to go through this real quickly because we are getting close to time. So I'm going to just talk and I'm going to work. And you can work along with me. And if you need to watch this tonight, then you need to do that. Yes?
There's something on your screen.
Oh, whoops, thank you. Okay, so we're going to multiply by I'm going to do negative 3.6. That doesn't matter, whatever you want to do. So I'm going to have negative 3.6P minus 3.6C equals negative 36. Then I'm going to copy this one over, positive 3.6P plus 7.9C equals 53.2. My P's will cancel. I'm going to do 7.9, take away 3.6, and I'm going to get 4.3C equals 17.2. I'm going to divide my 17.2 by 4.3, and I get 4. Well, this one's kind of easy. If I'm going to have 4 pounds of cashews, how many pounds of peanuts am I going to have? 6, because there's a total of 10 pounds in the mixture, right? So that one finished up pretty quickly. Okay, that's the last one.